Hi, my dear learners. Today we are going to discuss about what are conducting materials, what are semiconductors, and what are superconductors. Why you should know about all these materials. Being an engineering student, you should know about the materials and the properties because you are going to use these materials in different applications, different purposes. So you have to understand the properties of the material, how it will be behaved when it interact with another material. All these things you should know at the earliest stage because every day in this technological era, new materials are coming every day. So we need to understand what is the science behind, what is the physics behind in every material. So in that context, today we are going to discuss about the materials. So generally, the materials are classified into two categories, that is conductors and insulators. So what are conductors? You know very well. If a thing conducts heat or electricity, they are conductors. If it doesn't, it is called insulator. So what decides the conductivity here? What is one thing responsible for the conduction? That one thing which is very responsible for conduction is electrons. So in your lower classes, you might have studied electrons are the primary factor for conduction. But the electrons have to move. The electron has to move from one end to the other end or anywhere. There comes the current. Just the flow of electron produces the current. If the electrons are not flowing anywhere, if they are static in a place, they are called insulators. So based on the mobility of electrons, the conduction of electrons, the materials are broadly classified as conductors and insulator. There was a theory which elaborately discussed the primary fundamental things of the electron behavior, that is classical free electron theory. So this theory was proposed at the early stage of the evolution of science, particularly physics, the classical free electron theory. It is generally called as macroscopic theory because it only discussed the surface level information about the electron behavior, how it is very much based on the assumptions kind of thing. But later on, another theory evolved like quantum theory, which explained all the necessary things in detail in a microscopic way. So there are two theories. One is classical theory, which is a macroscopic theory. Another theory is the quantum theory, which is called a microscopic theory. So what actually the classical theory proposed? According to classical theory, the electrons are in a static position. The electrons are at rest when there is no electric field is applied. When the electric field is applied, the electron will start to move from one place to the other place. Without there is any electric field, the electrons are looking like the molecules of the gas. The molecule inside the gas can go anywhere. So it is in a random direction. So likewise, the electrons are going all around in a random direction when there is no electric field is applied. But when you apply any electric field, then all the electrons will align themselves in a direction which is opposite to the direction of the applied field. Wherever you are applying the field, the electrons will move opposite to that. So that is what the classical free electron theory mainly proposed at the initial stage. In classical free electron theory, we need to understand four important definitions. First one is drift velocity. So we know what is the normal velocity, but here it is called drift velocity. What is drift velocity? The average velocity of an electron due to the application of external electric field is called drift velocity. When the electron wants to move, it requires some external electric field. So once you provide the external electric field, the electron will start to move with the speed, with some velocity. So we need to take the average velocity of the electron. That average velocity is called drift velocity. And the second definition is mean free path. The average distance traveled between two successive collisions is called mean free path. So when the electron travels, there may be possibility for collision. So what is the average distance it traveled between two collisions is called The second definition is mean free path. So what is the average distance the electrons have traveled? That is called mean free path. Then relaxation time. So once you apply the electric field, the electron starts to move from A to B. Once you remove the field, the electron will come back to A from B. So it is taking some time to relax to come back to the equilibrium position. What is the original position? So that time is called relaxation time. The time taken by the electron to reach its equilibrium position from the disturbed position is called the relaxation time. Then fourth one is collision time. So during the movement of electrons, the electrons may collide with each other. So here the definition for collision time is the time taken by the free electron between two successive collision is called collision time. So what is the time it took between two successive collision is called collision time. So these basic fundamental definitions will help you. After studying the important definitions according to classical free electron theory, the next thing is to know about coefficient of electrical conductivity and the coefficient of thermal conductivity. So how the electrons are responsible, how the electrons are behaving when the current is flowing through a metal. That is coefficient of electrical conductivity. There is a formula to find out the coefficient of electrical conductivity that we are going to derive. The next thing is the similar way, in a similar way, we can do the derivation for the coefficient of thermal conductivity, sigma. So once you find out what is K and sigma, the ratio between the electrical conductivity to the thermal conductivity, that is K by sigma, is directly proportional to absolute temperature T. So K by sigma is directly proportional to T, and K by sigma is equal to LT. Once you replace the directly proportional symbol as equivalent symbol, you have to add a constant. That constant here is L. So K by sigma is equal to LT. What is L here? It is a constant, as I said, which is called Lorentz number. So there is a value for Lorentz number. What is that? 2.44 into 10 to the power of minus 8 some unit. Okay. So we are going to verify this Lorentz number value according to classical free electron theory and quantum free electron theory. Once you do that, you will not get the exact answer for Lorentz number according to classical free electron theory. If you are following the way of classical free electron theory, you will end up with a failure because it won't give the exact value for Lorentz number. But when you follow the steps from the quantum free electron theory, you can get the exact value of Lorentz number. So there lies a drawback of classical free electron theory. Like this one drawback, there are many drawbacks in classical free electron theory. One such drawback is it didn't explain the black body radiation, Compton effect and all. And likewise, a lot of drawbacks are there. And these drawbacks are successfully dealt by the theory called quantum free electron theory, which is a microscopic theory. So generally, the classical free electron theory is assumption based, and the quantum theory is nothing but a proven model as far as the physics world is concerned.